So let's do an example of finding the differential of area in polar coordinates. So we want to change xy coordinates, we want to change them into polar, rho and phi. Okay, so we know that dA is equal to dx dy, but now we want to change it. dA is equal to something times d rho d phi. And the first method of doing this is by geometrical intuition. So I did it very fast in the previous video, so I'm going to do it a bit slower now, more clear. Just a quick reminder, do you remember the arc length? So if you have a part of a circle, okay, this is part of a circle of radius r, and you have an angle phi here, the length of this curve is equal to r times the angle. Okay, this is a general rule of mathematics. That's why the circumference of a circle is 2 pi times r, because the angle is 2 pi. So how do you calculate dA by geometrical intuition? What you have to do is, okay, I have two variables, rho and phi. So now I fix rho. What happens if you make rho constant? You get a circle. So I draw a circle with a fixed rho, and then I increase rho by an amount d rho, which is this distance here. And we assume that this is a differential increase, okay? So then you get a circle with a slightly higher radius, which is a radius rho plus d rho, which would be this circle here, okay? So you have increased from here to here. Then you fix phi, the angle phi, so your second variable. You fix it to a fixed value. So for example, this value of phi, okay? This is a fixed value of phi, which corresponds to a certain angle. And now you increase phi by an amount d phi, yeah? So you increase the angle by an infinitesimal amount d phi. Here I'm grossly exaggerating it, of course. So therefore you end up with another line, which is at an angle phi plus d phi. So now these two lines and these two lines that we were talking about, they intersect, they create this area here. And this area here, when the change in rho and the change in phi go to 0, it goes into this area, in the limit becomes a rectangle, okay? So of course here it's clear that this is not a rectangle because it's curved and so on, but if the angle is sufficiently small in the limit, it becomes a rectangle, okay? So what is the size of this rectangle in this limit? So clearly the size of a rectangle is equal to one of its sides, which has a size of d rho, because remember d rho was the amount we increased rho by. And the other side is this length, which we assume is equal to this length. So clearly in this picture they are not equal. This one is bigger than this one, because this radius is bigger than this one. But if this difference is very, very small, then these two lengths become equal in the limit, okay? And what is the length of these two lengths? It will be the circumference of this arc, which is rho times d phi, owing to the rule that I reminded you of earlier, okay? So therefore dA is equal to the product of the two sides, so rho times d phi multiplied by d rho, which we can write as rho d phi. And that's how you can find dA by geometrical intuition. Okay? Thanks for watching.